Cordial saludo, profesor. Mi nombre es David Torres Muñoz. Estoy en la Tecnología en Desarrollo Informático en segundo semestre. Y el título del resumen es Types of Collision and Their Main Characteristics, Coefficient and Restitution. The video explores the difference between elastic and inelastic collisions, focusing on the key concept of momentum conservation and kinetic energy in perfectly elastic scenarios. In a perfectly elastic collision, both the momentum and kinetic energy are conserved, meaning that the total kinetic energy of the system before and after the collision remains unchanged. To determine whether a collision is elastic or inelastic, the coefficient of restitution is used. This value ranks between 0 and 1, where a value of 1 indicates a perfectly elastic collision and a value of 0 indicates a perfectly inelastic collision. For example, when two billiard balls collide and bounce off each other, this interaction closely resembles an elastic collision because the balls retain much of their kinetic energy. On the other hand, if a truck crashes into a wall and doesn't bounce back, it represents an inelastic collision where kinetic energy isn't conserved in the same way. The video then explains in more detail the equations that describe the conservation of energy and momentum in these systems. It shows how we can simplify certain terms to find relationships between the masses and velocities of the object involved. In elastic collision, for example, an experiment using steel spheres demonstrates how certain terms cancel out in the equations, making it easier to understand the final velocities. This happens because in a perfectly elastic collision, the initial relative velocity of the two objects is equal to the negative of their final relative velocity after the impact. This concept illustrates the way velocities exchange or balance between particles after they collide. The video also introduces some algebraic techniques, such as factoring expressions related to the concept coefficient of restitution, which plays a critical role in describing how energy and momentum behave during a collision. The factoring of terms, like the difference of squares, is especially helpful here, as it simplifies calculation and provides insight into how their objects interact based on their initial and final velocities. This algebraic approach helps clarify how each object's speed changes after the impact, and they reveal essential insights into the motion of each other object.